Hello students, welcome to my YouTube channel. Today we are going to discuss about the model question paper of physics. This is a part 2 of this video. We have already done in the first part of the video, that is 20 marks MCQ plus fill in the blanks. Today we are going to discuss about 2 marks question, dear children. Without wasting the time, let us start today's class, dear children. That is part B of third main, dear children. Third main. The third main starts from 21st question. The 21st question says that they have divided the 21st question into two parts. That is, one is strongest force and second one is weakest force in nature. Name the strongest force in nature and name the weakest force in nature. You all know that the strongest force in nature is strong nuclear force, dear children. Let I write here, that is for 21st question. They have in Roman number. The strong force is strong nuclear force. For second one, weakest force in nature is gravitational force, dear children. That is gravitational force. Let us come to 22nd question. What they are asking, 22nd question means what is relative velocity? And another question they have tagged with that, when will be the relative velocity of two moving objects is zero. You all know that relative velocity means relative velocity is the velocity of one object with respect to other when both are in motion, dear children. Let I write here by star mark, the relative velocity is the velocity of one object. Velocity of one object with respect to another when they both are in motion, children. Its meaning is, dear children, when the two bodies are moving they are in the motion. For an example, this is a body A and this is body B. What is the relative velocity of body A with respect to B? It is called relative velocity, children. Next, the tagged question is, when will be the relative velocity of two moving objects will be zero? It is when the two bodies travels in a same direction at the same speed, the relative velocity will be zero. Let I write that with star mark, children. When two moving bodies this travels in a same direction at a same speed, children, at a same speed. When two moving bodies travels in a same direction at a same speed, the relative velocity will become zero, children. Will become zero. Children, because two moving objects travels in the same direction at the same speed, then they can't find which is the relative velocity. If the one body is moving slow and one body is moving fast, then only we can find the relative velocity. Children, here the relative velocity will become 0. Moving on to the 23rd question. It's an easy question, children. Differentiate between scalar and vectors. Let I will differentiate this. Let I will erase the board, children. Please take a screenshot or pause the video and take down into your notes, children. Okay, children. Moving to the 23rd question. 23rd question. They have asked differentiate between scalar and vectors. It is an easy question, children. Let I will differentiate. First, scalar and vector. Children, scalar quantity will have only magnitude, children. Let I write here. It has only magnitude. And for vectors, it will have both magnitude and direction, dear children. It has both magnitude and direction, children. Children, when we come to the scalar quantity, it is only one dimensional, children. It is only, let I write here, it is only one dimensional. When we come to the vector quantity, children, it is multi-dimensional, children. Let us give some examples for scalar quantity. It will be mass. I will write an example. Mass, length, time, children. For a vector quantity, we will give an examples. Examples are velocity, acceleration, and displacement. It's enough, children. Displacement. Take down into your notes or pause the video and take the screenshot, children. Let me move to the 24th question. Let I erase this, children. Children, 24th question. What are conservative forces? Give an example, children. They are asking what are conservative forces. Let I write the 24th question. Children, the conservative force means the work done by the force which does not depends on the path followed by the body. This type of force we will call it as conservative force, children. Let I write with the definition. What are conservative force? The work done by the the work done by the force which does not depends on the path followed by the body. This type of force we call as conservative force, children. The meaning is very simple. The work done by the force always does not depends on in which path the force is coming, children. Let me write then examples. They have asked. I will give an example also, children. Let I will write the example. Force means it will be spring force, gravitational force, and electrostatic force, That's all, children. The gravitational force never depends on the path. It is in India also, it is gravitational force, how much it will exerted by the force. In spring force also, it everywhere the spring force will be same for an object. The electrostatic force will be also. And let me move to the 25th question. Take a screenshot or pause the video and take down into your notes, children. And I erase it. Our 25th question says that, children, state and explain perpendicular axis theorem of moment of inertia, children. They have asked statement with explanation, children. I will write the first statement, children, for 25th question. For 25th question, statement. The moment of inertia of a plane lamina about an axis. This is statement about an axis is perpendicular to its plane which is equal to sum of moment of inertia of two mutually perpendicular axis, children. Perpendicular axis. The statement says that, children, the moment of inertia of a plane lamina about an axis is always perpendicular, children. Perpendicular means like this. Perpendicular means like this. Perpendicular, which is equal to sum of moment of inertia which is equal to sum. It means the addition of inertia of two manually perpendicular axes. This is perpendicular symbol, children. Let me explain the perpendicular axis theorem. I will explain, children, with diagram. Without diagram, it will not carry any mark, children. Diagram is very important for the derivations. Let I give the name Z, Y, and X. It is a center O, and this is moving. Children, let me give this as a, this is the distance as a y, this distance as the x, children, and this is, we will denote it by n, and we will give this as a p, this is l, and this is r, and this is also y. Okay, it's enough, children. And it is the moment of inertia for a perpendicular axis. This is P, children. See, children, here we have three axes. Axis Z, and axis Y, and axis X. By this, we want to prove, children. Read the statement. The moment of inertia of a plane lamina about an axis perpendicular to its plane. Here, inertia of Z, that I write here, inertia of Z should equal to inertia of Y. Inertia of Y plus inertia of inertia of X, children. It means that what is the moment of inertia? It is mass into summation of direct displacements square, children. Let me derive this. Let us take Iz equal to, means inertia of Z axis. We will give the summation as the integration. What the moment of inertia says? It is mass into square of the distance or a displacement, children. The integration, except the summation we are giving, I am writing integration. We want to integrate, children. Integration of Iz means it is R. It is R. For small angle, what will be the mass? We will take a small mass as dm, children. That I write here dm. It is a mass into distance square. What is the distance? It is r square, children. It is r square. Next, Iy is equal to, the mass is same, that is dm. The integration of Iy means it is an x, children, and x-axis means x square. Inertia of x we want to find out, children. Integration of dm as it is, because the mass is same for a small mass. Next, for this we have then y. This is an distance, children, means distance square means y square. Let we got this inertia of z, inertia of y, and inertia of x. Let we take triangle. Sorry, L is here. LOP, children. Let I take triangle LOP. What is Pythagoras here, children? This is 90 degree. 90 degree is opposite is hypotenuse. Hypotenuse square is equal to other two sides. Means this is important. This means r square is equal to x square plus y square, children. It means that what is r square? Integration of r square into dm, and integration of x square means it is y square dm, plus dm means small mass, and next integration of x square dm. See children, what we have, integration of r square dm, iz is equal to integration of y square dm means it is integration of inertia of x plus sign we have. I have took the plus symbol. Integration of x square dm is integration of y, children. This what we got, the perpendicular axis. What we have to prove? This we have to prove, children. We have got the answer. Take a screenshot or pause the video and write down, students. I will erase this now because we does not have space. The board is very small, children. Please adjust that. Children, next we move to the 26th question. 26th question says that write the relation connecting small g and capital G and explain the terms. It is a very easy question, children. 26th. It is small g and capital letter G. What is the gravitational force? Gravitation. It is very easy, children. Gravitational force means F is equal to, you all know the formula, means equation G m divided by r square. We know that F is equal to mg, children. Mg. Let us substitute F value is equal to mg. What happens? Mg is equal to G m divided by r square. I wrote like that only. This term has came here. Let me cancel m. What is G? Small g. It is equal to G m divided by r square. This is the relationship between capital letter G and the small letter g, children. They have said explain the terms. Now I will explain the terms, children. Small g means, you all know that small g means acceleration due to gravity. Acceleration due to gravity. Capital letter G means it is universal gravitational constant, children. You all know that. Universal gravitational constant. M means mass of massive body. They have asked to explain the terms, so I am explaining the terms here. M means mass of the massive body. Next we have left that R. R means radius is of massive body, dear children. We have got the relationship between small g and capital letter G. Take down into your notes, dear children. Let me move to the next 27th question. I will erase this. Twenty-seventh question says that write the differences between isothermal and adiabatic processes. It will comes in the thermodynamics lesson. You all know that. Let I differentiate. We should differentiate like this only, children, by taking the two columns. It is the manner of differentiating anything. First they have asked isothermal process. I will write isothermal, thermal, and adiabatic. Adiabatic. Children, isothermal means there is an exchange of heat will be occur. There is a transfer of heat is occur. Here I will write that the transfer of heat. Heat occurs. The transfer of heat occurs. Here there is no transfer of heat. There is no transfer of heat, dear children. Here the pressure will be more for a given volume, children. For an isothermal process, the pressure will be more for the given volume. If I write here, the pressure will be more for a given volume, dear children. Here it will be opposite. The pressure will be less. The pressure will be less. Will be less for a given volume. And next we come to the isothermal. Next point, another point I will write. That's all two we need, but I will write extra one. Here the transformation is slow, dear children. Here the transformation is slow. Here the transformation is high, means this transformation is fast, dear children. The transformation is fast. We have given three differences, children. Let me move to the 28th question by erasing this. Pause the video and take down this, children. So we are moving to 28th question. 28th question says that mention any two postulates of kinetic theory of gases. They have asked a 28th question. Mention any two, children. We need to write any two. The gases will be more randomness, children. the gas does not have the fixed shape or the fixed volume. It means the molecules, let I write two postulates, children. The molecules of gases move in random. Children, there is no fixed shape for gas, so the molecules of gases move in random motion, children. Random motion. Next point, the molecules will have kinetic energy, children. This is very important. The molecules contains kinetic energy. That I write here. The molecule will have kinetic energy, dear children. Energy. Third point, they are asked only two. Let me write three. There is an exchange of energy between the container, children. This is also very, very important. These 2 points are very, very important. There is an exchange of energy between the containers. There is, let I write, there is exchange of energy between the container, dear children. Next we move on to the last question of a 2 marks, that is 29th question. Let I erase this, pause the video and take down into your notes, dear children. Let I read the last and the final question of the 2 marks, children. What are transfer waves? Give an example. What are transfer waves? Let I write here the 29th question. They ask a transverse wave are the type of progressive wave, children. Type of progressive wave. Here the transverse wave are the progressive wave. Here the direction of the progression, the direction of the propagation of transfer wave, that I write here, the direction of propagation of transverse wave, transverse wave. Oh, I will transverse wave is always perpendicular. I will write it is perpendicular to the direction of vibration, children. Direction of vibration. Children, the transfer waves means the transfer wave are the type of progressive. They are the type of progressive wave. The direction of propagation of transverse wave is perpendicular to the direction of vibration. It is perpendicular. Perpendicular, I have already said. It means like this, children. It is perpendicular to the direction of vibration. They have asked an example. We will write the example. First example, electromagnetic wave. Electromagnetic wave. Children, you will learn electromagnetic wave in your second PUC. Children, now the example is enough. Next example I will give, light wave. Light wave, dear children. For the 29th question, the 2 marks questions is over. I hope you have understood today's class. Share this video in your groups and as well as to your friends. Thank you, children. If you have not yet subscribed my children, please subscribe to my channel and hit the bell icon, children. Thank you. I hope you are all doing good.